Two-way tables practice. Number 1. The two-way table below shows the results from a survey of female and male students about whether or not they prefer math or language arts. Complete the two-way table and find the relative frequency from to the nearest hundred of male students that prefer math to all male students surveyed. Hint, find the relative frequencies by row. Alright, so for our males, we have 38 like math, 12 that like language arts, so that's a total of 50. 17 that like math, 33 that like language arts, that's a total of 50. We surveyed 100 altogether. For people who like math, that's 38 males and 17 females. When you add those together, you get 55. For language arts, that's 12 males, 33 females. You add those together to get 45. So that is the cumulative frequencies completing the two-way table. Now find the relative frequency of male students, so we're looking here for males, that prefer math to all of the male students surveyed. So that's going to be 38 out of 50, which is 76 hundredths. To get the percentage of that, move the decimal to the right 2 places, and that gives you 76%. Bill is a new student who just transferred to Berkmar. Is Bill more or less likely to enjoy math or language arts? Explain how you know. Bill is more likely to like math because 76% of the men prefer math. Number 2. Juan was curious to discover middle school students and high school students like the same gaming consoles. He surveyed 100 students and found the following. 27 of the 50 middle school students preferred PS3 out of 50, and 24 out of the high school students preferred Xbox, and we have a total of 100. If 50 of the middle school students is our total, and 27 of those like PS3, then that leaves us with 23 that likes Xbox, and if 24 of our 50 from high school like Xbox, then 26 like PS3. 23 plus 24 gives us a total of 47 that like Xbox, and 27 plus 26, when you add those together, you get 53 that like PS3. So we completed the two-way table. Now find the relative frequency by column. So for Xbox, 23 out of 47 kids prefer, from the 23 students from the middle school, out of the 47 total students like Xbox. So that's going to leave us with 49 hundredths, so that's 49%. For the high schoolers, that's 24 of the 47 are from the high school, so that has those 51 hundredths when we divide. Do the same thing for PS3. We have 27 out of 53, which is 51 hundredths, so that's 51%, and 26 out of 53 is 49 hundredths, which is 49%. According to the data, would you say that the middle school students and high school students have similar or different preferences? They have similar because 49 and 51, 51 and 49, those are very close to being half of the middle school, half the kids that like Xbox are middle schoolers, half of them are high school, almost half of them like PS3 that are middle schoolers. Those that like PS3, almost half of them are high schoolers. They have pretty similar preferences. Let's look at number 30. With summer quickly approaching, teachers were attempting to determine if they need to offer swimming lessons for students. Answer the following questions based on the data. So we're looking for a percentage that cannot swim. So in order to do this, we need to see how many total do we have that cannot swim? That's 120 plus 180 plus 265. Which is 565 students that cannot swim. So now I need to find the percentages. Well, let's start with A first. A says how many 8th graders were surveyed. So let's look just at 8th grade. Forget what we just did. Just at 8th grade. Total students that were surveyed is 265 plus 35, which is 300. Now let's look at B. By simply looking at the data, which grade would you expect to have the largest percentage of students unable to swim? By just looking at it, you would assume that the 8th grade would have the largest unable to swim because they have 265, which is more than anybody else. But we have to calculate the percentage of students for each grade that cannot swim and fill in this table to see if that is accurate. So we're actually going to do this horizontally instead of vertically. We have 300 total 8th graders, and there are 265 out of those that cannot swim, which is, when you divide that, 88%. We have 200 7th graders, 180 of them cannot swim. When you divide that, you get 90%. And then for 6th grade, you have 180, 120 of them cannot swim. So that's 67%. So actually, 7th grade has the majority of students that cannot swim instead of 8th grade. Let's look at number 4. There were 100 customers in a restaurant that were asked whether they liked chicken or beef and whether they liked rice or pasta. Out of 30 customers that liked rice, so there's a total of the 30 that liked rice, 10 of them liked chicken. There were 60 customers that liked chicken. So out of the 30 total customers that liked rice, 20 of them liked chicken. And there were 60 total customers that liked chicken. So we need to fill in the rest of this based off of what we know. We know that we have 100 total. So if the 30 of our 100 total like rice, then that leaves us with 70 that like pasta. If 30 that like rice, 20 of those like chicken, and there's 10 left that like beef. If there are 60 that like chicken out of the 100 total, then 40 of them like beef. If 40 total like beef and 10 of the 40 like beef like rice as well, then subtract that and you will get 30 like beef and pasta. And then if there's 70 total that like pasta and 30 of them like beef, then when you subtract that, that leaves you with 40 who like chicken. Look at number 5. As each person entered the theater, Aaron counted how many of the 105 people, that's our total, had popcorn and how many had a drink. He found that 84 had popcorn out of the 84 people that had popcorn. So our total for popcorn is 84. Only 10 did not have a drink. So 10 of these 84 that had popcorn did not have a drink. 6 people walked in without popcorn or a drink. So no drink and no popcorn is 6. So now that we have these, we can fill in, figure out what we know. We know that the total that had no drink is 10 plus 6, which is 16. There's 105 total, 16 of which did not have a drink. That leaves us with 89 customers that did have a drink. We have 84 total that like popcorn, and take away the 10 that didn't have a drink, that leaves you with 74 that got popcorn and a drink. If we have 105 total, and 84 of those got popcorn, then when you subtract that, 21 of them did not have popcorn. And out of the ones that did not get popcorn, only 6 of them did not get a drink. So that means 15 of them got a drink but did not get popcorn. And that is all you have to do for number 5. Look at number 6. Matt wanted to test if a person's intelligence level is in any way related to their preference for Justin Bieber. Therefore, he surveyed several of his friends by asking them 2 simple questions. Do you currently possess a B or higher in your math class? And do you currently own a Justin Bieber album? Matt recorded his data into the chart seen below. It wasn't until after he recorded this data that he realized it would be much easier to analyze the data in a two-way table. Help Matt create a two-way table below to help him answer the following questions. A. What percentage of his friends own a Justin Bieber CD? So, he asked a total, all of his friends, of which these 2 questions. So let's first look at the kids that own a Justin Bieber CD. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 50 of them own a Bieber CD, so own Biebs, and have an A or B, that is 50. 5, 10, 15, 20 of them that own Biebs have C or lower. That gives them a total of 70 that own Biebs. The ones that have no Biebs, 5, 10, 15, 20 of them have an A or B. 5, 10, 15, 20, 25, 30, 35, 40 of them have no Biebs and a C or lower, which gives us a total of 60. So, 70 plus 60 is going to be 130. 20 plus 40 is going to be 60. And 50 plus 20 is 70. 70 plus 60 is also 130. So what percentage of his friends own a Justin Bieber album? So you're looking at those that own a Justin Bieber album is 70 out of 130. When we divide that, we get 54%. What percentage of his AB friends own a Justin Bieber album? So of his AB friends, of the 70 friends, 50 of them own Justin Bieber. So when we divide that, we get 71%. How many more of his friends have an A, B in math than a C or lower? So of his friends that have an A or a B, there are 70 that have an A or B and 60 that have a C or lower. And when we subtract that, that leaves us with 10 friends that have an A or a B more than those that have a C or lower.